Okay, so if you do not have any questions, the first thing I want you to log into the SendGate and you go to the download your data file. And it's just you have the unit 7 and unit 8 data file. It's that you have many programs and work with this stuff. How to download it? Is it? I have. So in the module 7, yeah, you have the, some of the module here already, some of the program here already, and for the module 8 also. Yeah, so basically some of the example I show in the slide later on, you can see you can see it from here in the student part. You can work around with it. Exactly what. Okay, so today we learn about the simple graphic and image processing, and that is some of the steps you need to know in order to work with the final project. In the final project, you work with the graphic. Okay, simple graphic. Graphic is it is underlie the representation and display the geometric shape in the 2 or 3 dimensional space. And in the Python, you have the one where toolkit is a turtle graphic. It's very simple, provides simple and enjoyable way to draw a picture and window. It is non-standard and open source for the Python module. Okay, so that is some of the history of the turtle module. So basically, in order to work with the graphic, you need to understand some of very basic definition in the screen here. Where's status?
It should be on the other side.
Okay. Okay. So basically, when you break it down in the screen, you always have the break it down in the pixel, right? You break it down in the pixel, you have the position of the pixel, and pixel includes of the 2 index here. You have X and Y, right? So you see when you break it down in the screen, you have this one is X here, and this one is Y, right? So you can think about if you break it down the screen into the 4 parts, right? And at the center of this is X and Y. You have the position of X and Y is 0, 1, 0 here, right? 0, 0 here. So the X is everything is a horizontal. Everything is horizontal, and Y is everything is a vertical here, right? Okay. So what is it? For this one, you see, if you have 1 and 1 here, that's the position of X, and you have 1 and 1. Okay, 1 and 1 here. So what happened if I have? Can you show me what is the point where I have the -1 and 3 here? Where it is? Which one?
1.
Yeah, so you have you have the -2, so we have to go to the horizontal 1 and 2 here, right? And number 3, you have to go to the up here 1, 2, and 3 here. So that is the -2 and 3 here, right? So that is the first concept you have to understand in order to work with the graphic here. You have to know the book. You have to know everything about the pixel definition, and you know everything about the X and Y position here. Cool. So basically, when we work with the graphic here, basically when the first time when we work with the graphic, right, you have the coordinate system, and at the beginning, whenever you starting with the graphic, the X and Y is always starting at the 0, 0, and always starting at the center of the window here, right? So if you open the window, the original at the beginning X and Y is always starting at the 0. Okay, so you have the sum attribute of the total, you have the heading, you have the color, and you have the width and down here. So heading, that means tell you where you want to head it to the coordinate of X and Y. So think about at the beginning you have the 0 and 0 here. So at the beginning. Okay, at the beginning you have the coordinator. Why I cannot draw it anymore? I just draw it. But now,
did you click on the draw? That's a good question. This
draw, yeah.
No, this isn't the right way.
Yeah, it's not that one. I think sometimes
The zoom
I
is.
might try to share again. Yeah, that's wrong, the wrong one.
Okay.
Yeah, the wrong one.
And then it should work now.
Okay, yeah.
Yeah, it does work.
Okay, so the first time when you open the window, you have the coordinator of X and Y as a center of the window, right? And you can use the method heading. It tell you to which position you want to go, right? So you can tell the heading and you go to the 1 and 2 as the mouse will move to the position of the 1 and 2 here. You have the color, that the method is set the color of the line or whatever you want, right? The width and the depth is also the attribute of the line you want to draw. Okay, so we have the sum of the method here. You have when you go to the total operation, you have the t equal total. That is when you create the instant here, right? It creates the instant, and the object open with the window. You learn it from the module 7 already. When we learn about class, we learn about instant, we learn about object, right? You have the t home, it's moved to the center of the window, to the coordinator of 0 and 0. And have the t up, that means you raise the pen up, right? You raise the pen up. And have the t down, you put the pen down, right? And you have the set head degree. So basically, you see, by the default here, when you're starting with the window, you're starting at the center of the window, right? Starting at the center of the window here. And the direction of the mouse is always go to the right here, right? That is the first time you pick that is the direction of the mouse, right? So see, when you set the set head here, you can set the degree. Now think about if you want to set it 90 degree, it will heading to the vertical on this one, right? And if you want to set it to the 128, it will go on the opposite direction, right? And so on. This one is the one. This one is a 270 degree here, right? Okay. So that you have the t heading degree, right? Direction, right? You have the t left degree. So move to the left, or you can move to the right. And the to go to move to the specified position. And the to forward, let's see, when you put the pen down and you want to move forward to what direction it is, right? And it tell you what is the distance you want. So you are able to set the color here. The color is a combination of the red, green, and blue, right? So in the range of red and green and blue, it's everything from 0 to 255 here. Right? So if you have everything, the red is 255. It's really red, but yeah, right. That's one you understand here. The pen color, the string equals also. You can start the string here. You can put the red or green or blue, whatever it is. Right? So that is a fill. That is a fill color. If you want to shape here and you want to fill it here. Okay. So also we have the some other one. You have the T, BQ fill and fill clear, and you set the width, right? Or you can hide the total. You see, hide the total, the one you draw it here. You can hide total or you can show total, and you can return what is the current position of the total. And why have the T heading again? Okay, set heading at T heading. Okay, return the current direction of the T, and it's down. If true, if the pen is down, or 4, it's not here. Right? So that is a Boolean. So okay, to work with the total, it's very simple here. It's very simple. That is example when we draw the square here. So you know that in the draw the square, you have to move it into the four side, right? You have to move it in the four side here. So think about, you have 1, 2, 3, and 4. That's the way you draw a square, and they are equal side, right? So this one here, you import the total. You import the total. You define the function here. That one is the object. That one is the object total, right? You have coordinate of x and y and the length. Length, that means the side here. How many? Here. So you have t up. You move to the pair up, right? You move to the position of x and y. So by the default, it's starting from 0, 0 here, but it's up to you. You can move to whatever you want here. You can move to whatever you want. It's up to you, right? So at the beginning, move up, and you go to, right? Now the set heading. Set heading is 270. 270. So we see by the default, it always show in the direction here. That always show in direction here. But now, if you want to starting from the first one here, if you want to draw this first one, right? So we have to move everything from here to here. It's 90, 180 degree and 270. Right? That's why you have to move it to what? 270. Now you move the pen up. You move the pen up. You go to the position. You point out the direction. That's the direction you want to go. Right? Now you just put it down. Put the pen down. So you see, you need to do it 4 times, right? 1, 2, 3, 4. That's why you have the loop here. 4 times. For every time you do forward length. Sorry.
Pen's gone. You gotta press the draw again.
Why?
You gotta press the draw again.
Okay.
There we go.
So here, you see, for each time you move it to the length here, right? But you see, when you're done with this one, you have to change the direction at 90 degrees, right? That's why every time you move to the one, you draw the one, you change direction, move, change direction, and move here 4 times. Right? So that is very simple program. You can see the total here. So let me see. I run with this one. Oh.
Just discard it.
Yes, so see, 1, 2, 3, 4. Oh, this one is terminated. When it done, exceeded. So it should be input here. Okay. Yeah, that is the way it works, right? That is the way it works. So what you can go back to the program here. What is the first thing? You move to the negative 200 and 200, right? So you see, if you analyze the problem here, you can see it here at the beginning. You standing at the center. Standing at the center here. So you move to the negative 200 and the positive 200 here. That's the first thing. Now, when you move it, remember you have to raise the pen up, right? Otherwise, it might be here. So you have to raise the pen up, and you know that by the default, it always the direction on that way, right? So by the default, and now you want to start with this one. That's why you have to move 90 degree, 180, and 270 here. Right? So now, when you move to this one, you move to the first one. Now, see, if you're standing from here, by the default, when you change direction, it always turn left. Always turn left by the default. Right? That's why it turn it left here. You can see, turn it left here, 90 degree, right? 90 degree, and again, do it one more. From here, turn left again, 90 degree. Turn here, and this one. That's the process. Huh? That's the process here. Now, think about this one. if you look on this program, my question here, how can you modify to print out the hexagon? Hexagon is how many sides? Six sides, right? Okay, how can you do it? How can you modify this program to print out hexagon? What do you think?
When the angle of the turn is to start, can't start facing 270.
It could, it'd just be rotated.
Oh, yeah, it would just,
Yeah, but that is the first time rotation. Okay.
so
Left has to be 120, if that's degrees, it has to be 120, and then you have to change the range to 6.
Okay, now see. That also I think that is also my mistake for the first time. You change it to 6 here, right? And you take this one 120 here, right? No. Yeah, you see. That's the problem.
so
we have to, instead of 120,
Oh,
make it
wait.
60.
60, yeah. That's
60.
because you can think about this one here, right? You can take one here.
No, it's 120 is based.
Now you see, you are here, right? Now you see, if you are here, you want to draw the hexagon. So that is the degree you change. Yeah. So that's why actually it's a 60.
Yeah.
Not 120. That's not the first time I make the same mistake. Yeah. So basically for this one, you have
120 is the inner angle, but it's
Yeah.
not useful. Okay.
So we have the 60 here. Oh,
Yeah.
wait.
Yeah. We just
200 may be a bit much.
No, if the length can be shorter, then we can see it. Oh, that's
Not you have
No.
to read
the length has to be switched.
the length.
Yeah.
Sorry,
For
I
that
make
length.
a mistake with the length.
The
It's the length here, right?
yeah.
That's the length. Yeah, it's about 150 here.
I have no idea what the reference is, but
There we go.
Okay.
And now you need to move to starting position.
I mean 150. is
Yeah.
fine. I guess that works too. At least we can see it now. Yeah.
And of course, you can hide the total. And you have the method, right? You have the method. You can hide the total. So that's it. You can use the method here. After you done this, you have the total. Hide.
Oh wait, you put tuple, not turtle.
Oh, sorry. Okay. What?
There's no high.
Oh, really? I see it already here. I believe you have. English gentleman must be. Oh.
It's called high
High
turtle.
total. Okay. High total.
Oh,
So we
the
have
command is longer. Oh, you missed
this
this.
one. Yeah. Okay, so basically it's very simple with the program here. And go on this one. This one when you can set it up the environment. So at the beginning, every time you run it, always starting with the window with the width of 600 and height is 600 and idle 2 and color mode 255. That means it is a black. Okay, so that is the way you initiate and you generate instant. What we learned from the last class already. You learn about the object and how we generate instant from that. So this one you import total from the total here, right? And you define and use it generate the instant from that one. Okay, so if you want to close this, click the close. Okay, and here's what is it? You can play around with this one. You can play around with this one. And you set the width here. It's a 2. Let's see. We can play around to see play around here. Total. What do you have here? Total width. Set it to 5. What else? Pen color. Let's see. Pen color 30. What else? Pen color. Okay. Let's see. Okay.
You have to put red in quotes.
Okay.
There we go.
Okay, so basically that is very simple, right? So you can modify whatever you want for this one. Okay, so that is now you want to draw the 2-dimensional shape. You want to draw the 2-dimensional shape for this one. But how can you change? How can you change the setting? The settings that work anytime I show it. So I think in this I show. I think.
What are we trying to do?
Yeah. So you see, every time I show it, I have to change this one. Swap.
We could, if we go back to that setting, could try and change it. What is it? It is slideshow monitor instead of saying automatic. Always do. I think it's.
If I choose this one, I lost this. Yeah. Oh, okay. Okay, so that's the way you draw the 2-dimensional shape. So Magic Graphic application is a vector graphic or drawing the simple 2-dimensional shape, rectangle and triangle. So go here. That's it. Polygon. So we only have the polygon. So from that polygon here, you import the total. From that you import the class. You define the 2 function. You have the object here, and you have the length. In that you print out the square, right? You have the hexagon. You have the print out the hexagon. So now from the polygon, you import everything from total. Import total. You set the total. You set the pen color. You drag the height total. Okay. Now you call out the function here. You call out the function T and the 50 and hexagon T the 50 here. What is it? Now let's see. We go to the polygon here. So I start into the one. Two-dimensional. And polygon, right? Yes, this one. So for the polygon, you define the square hexagon. Okay, define the radius hexagon. and you define gradient pattern here. So we have T. Yeah, and okay, this one in general, right? So see, from this one you can draw whatever you want. You can draw a square, or you can draw the pentagon or hexagon. It only depends on the shape, right? It depends on the shape. So think about if you add the square, you know that you have the four side, right? So see, you have to enter for this one. If you enter the square, you have to put the number 4 here, and the shape shape here is a square, and you call out the function shape, right? So think about, we put the square here, it call out the function square, right? And if you put the function hexa here, if you put the hexa here, it call out the function hexa, right? The only difference between them is that how many sides you want, right? That's the first thing, how many sides you want. So for this one, you have the 1 parameter here, and you have the 2 parameter here. That is the define what shape you want, right? Make sense? So we have the square. Yeah. If you have square, you have number 4 here, and this one is a square here. Right? And if you want to, you have number 5 here, and the shape is a pentagon. But I do not define the pentagon here. So basically, if you want to do that, you have to do one more pentagon. And this one pentagon is 5 sides, right? 5. Forward length and 236 divided by 5. What is it? 8. It's 7. 722, right? 72. Yeah, 72. Okay. So yes, that's the way you define the polygon here. That's the way you define any shape you want. That's the way you define any shape you want. You can define square. Square, you run it 4 times, and you have in total. In the total, you see, in the total you have degree here. You have the degree, all of them. You have the 360, right? So if you have the 4, you divide by 4 for the square. If you have the hexagon, you divide by 6, and you have the pentagon, you divide by 5. Okay, that's the way you work with this one here. And and here's this. Oh, okay. This one is in general here. Whatever it is, right? So whenever you want the whatever it is, so it can be the 4 here, or it can be 5 here, or it can be 6 here. It only divide by how many sides you have. So that is the way you divide this one. Okay. So now for the 2-dimensional array, you import every thing from the polygon. Right? So basically, you import everything from here. You import from total. You generate the instant the t here. Right? You set the red. You hide it. You move it up. You go into -100. Now you put it down. You draw a square. You draw a square up to go to the. Okay. So basically, this one you can see. This one you can break it down screen here in the 4 part. Right? You can break it down screen here in the 4 part. You move to the -200 here. You draw a square here, right? And you go to the -200 and -200. You draw the hexagon here, and you go to 200 and 200. You draw the this one here. This one you define it here, right? So this one it has the S size. You can do it here. Whatever it is. And again, I think the last one is that the last one. What is it? The last one he do the hexagon here, and the last one he do. Okay. This one is square again. Okay, so let's see how it works in this program. See how it works in this program here. Yes, move to this one, move to this one, move to this one, and move to this one, and go to this one also. Interesting. I see. He do the two.
Interesting shape.
So basically you have to do the loop here, right? You have to do the loop here, and for every iteration of the loop, you just shift the direction. Alright. Now see, what is it? 200. No, for this one, 300 radian per second. You do radian per second. You starting from this one. Sorry, starting radian pattern here. Radian pattern. So see what is the radian pattern? Radian pattern.
It's a count loop.
Where? So where's the loop? How can you do the loop here?
The radian pattern.
Radian pattern T 10 here. Yeah, okay, 10. Let's put the yeah, 10 here is the loop, right? 10 here is the, so 10 here, that it do it for 10
And then
times.
it's calling the shape.
Okay. Okay, so okay. Oh yeah, just that's called the shape. So my mistake here. So basically, this one is called the function shape, right? And it do it for n time. It depends on how many you want. And of course, if you do 10 times, so every time you have to shift it for the 36 degree. So in order to make it up the whole 36 degree here. It makes sense? Okay. Or for this one, you can do. So I don't want to do square here. Next way I do pentagon here. Alright, so we can run it again. Yeah, that's it.
That's working as intended.
Yeah, good. In the center, now that the hexagon. That the hexagon. This is the pentagon.
That used to be a bunch of squares.
Okay, so basically you can modify whatever you want. You can modify whatever you want. So it's better I put it input here, so it's not shut down. After you run. Okay, so yeah, you see when you download the file, you have a lot of program here. You can work around with that. You can play around with that, whatever you want. Honestly, it's quite simple, it's quite straightforward. So you can modify whatever you want for this one here. So that is the way you define the radian hexagon here, right? So you have to define how many times you want to run. Right? So we are here. So see, every time you do one iteration, you have to shift the degree here, right? That's why you have the 200. You have the 360 you divide by for the how many patterns you want. Okay, so very simple with this one. Yeah. Okay, and sometimes you want to examine the object attribute, right? So you know that you have the mutator method and you have accessor method. The mutator method, that means you take it out and you modify it. You take it out and modify it. But accessor method, you just react to the value and you do not change anything. You do change anything. So for this one, you see when you define when you generate the instant total here, you can get the position. That is accessor here. So what's the position? 0.0, 0.0, right? And you can set the heading to the degree, or you can check if the condition if the pen is down or not here. Right? So basically, that is the accessor. You can get it here. Okay, so now you can manipulating the total screen here. Right? So in that one, when that one you have the access the total screen object using the notation T screen here. This screen here is return new, right? It's return new with the attribute of the screen. So for this one here, when you generate the instant with the total, right? You have the title screen and the background color. As you can set what is the background, And you see when you have X here, return what is the window width, right? What's the window width right now? And you can divide by 2, and you can see you can have what the Y now. You can divide by 2, and you can take it out. What is the position of negative? Sorry, you can print it out. What's the position of the of negative X and Y and X and Y here? So I think that for this one should be better. We do with the see what's the beginning here. I see what is the beginning. I do with this one. I print it here. After that, why? I saw this. Why not here? So it's suppose we have to print now X1 Y. Okay. That is a screen. The better I do. Not work. Nice check. So we set for okay, I got it. So yeah, you just print the screen. It's print is the screen of the minus X and yeah, minus X and Y here, right? And X and minus Y. And you have to break it down too, right? You have to break it down because the width and the length, everything about the window. So basically, starting you have to do with it. This one, that's why you want to print it out the window here. Into window here. So if you want to print out the window, right, you have to move everything from this one. You have to move everything from this one. And that is the first thing, and you have to move everything from this one here. That's why you have to divide the width and the height to number 2. And it return you with a screen of the window. Okay. Now that is the function of the random walk. Random walk. Let's translate this program we have here. Random walk here. So what is it? What's the random walk here? Let's see what is the random walk. You can translate what it is. From total, define the random walk. You have the t turn and distance here for x in range of turn. How many turn, right? Turn is that how many turn is a turn, whatever it is. And if x divided by 2, so if x is a even number, and you turn left. Okay, you random. You turn left. You turn left with a random degree. That's one is random degree. And if it's odd, you turn right with a random degree. And for every time, it move it to the distance here. Right? So basically, it's also quite simple. So we have to put here. Let's see what is going on.
Just hit the green retry button.
This one?
Yeah. Error. Does not match any indentation level?
Where? This one?
Indentation error, yeah.
Why? I put it correctly here. Something is right there. Something pattern right here. No. That pattern.
You're putting in a definition, not in the, below the main.
It should go into the definition, otherwise it would never execute.
Yeah.
I mean, I guess you can put it after the main if you want, but
So,
I don't think it's gonna, it might complain less. Not that that should make any difference.
so we have to do it for T10.
Mhm.
Right? And yeah, have to do it for T10. Okay, so I think it's too simple with this program. Okay, so okay. Now talking about the color and the red and green, blue and system here. So basically, when you draw in the pixel in the screen, you can choose whatever color it is. So it's a combination of the red, green, and blue. It's a combination. It's R here stand for red, and G stand for green, and B stand for blue. So it's a range for every color. You have a range from 0 to 255. That the 0 is very almost nothing, and 255 is very strong color here. 0 is the essence of that color, and 255 is the maximum of that color. Okay, so we see when you combine them together, you have to combine them together. Each color component requires 8 bits here. So we have the 8 bits. That means each color you use 8 bits. That's why you know you have the 8 bits. That's why you have 2 raised to power. You have the 2 raised to power 8. You have 256 range, 256, and that's why you see you have everything from 0 to 255 here. Alright, so when you combine them together, you have a huge range of color here. That's what you see. You have in total, you have each of them is 8 bits. So if you have 3 of them, you have the 24 bits, and of course you have 24 bits. That means you have 2 raised to 24. That is in total we have that range of the color here. So basically, if you want to work the black, all of them 0, right? And if you work the white, all of them 255 here. And you see, you have the red only here. Right? You have green only here. Blue only here. And you have yellow. It's a combination of the red and green. That's why you have this one, right? And so on. So basically, you can search it up in the web if you want to see what is a component, what is the value of the red, of green and blue, to make it think about what happens if you want to print a purple. What is it? Purple is a combination of
Red and blue.
A green and blue, right?
So red and blue.
I don't know. I have no idea.
Purple, red and blue.
Red and blue.
Yeah.
Okay, red and blue. Okay, so we can set it the 255 here, right? 255 here. You have 0 and you have 255 here. Right? So whatever I did, it's totally flexible with this one. So this is random pattern again. Why the random pattern again? I know it's a random pattern. You have not to do it. Right? So random pattern, what's it? What's the random pattern here? Random pattern. You have total, you import the polygon, you already do it here, right? So draw the pattern. Draw the pattern, you have the T, here X and Y, it on and the right count here. Calculate depend on the shape. You have the square, you have the 4, you have the pentagon, you have 5, and so on. That's what you already define in where? Yeah, you divide on in here already. Yeah, divide in here already. So okay, that is random color here. See, it's a pure random. See, you have the red, random, everything from 0 to 255. This one also random. This one also random here. Right? And after that, you just draw the shape, whatever you want here. And you break it down, the width and then draw the pattern. Yeah, starting from that one. That's it. Put here. You can play around with your program if you want. Oh, okay. So
Going speed style on this one.
good.
Why did it go so fast this time?
Yeah, that's a good question.
Oh wait, no, it's because there's not that much length, is there?
Oh yeah, all right.
And I had to spend time actually drawing out the other ones.
Mm, all right. Yeah. Let's see. Let's see how well. Left here. Square you have the 30, but the hexagon you have the 20 only. Now see, if you increase it here, 60 here, 40 here, it slow down, right? It slow down on this one. Slow down, right? No,
No,
it's
that's still
slow down.
pretty fast. Why is this one
It
so
works very
fast?
fast. Any idea?
Technically, the length that we've chosen before was like 100, like 200.
You know, it was an order of magnitude bigger, so again, that still holds up, I suppose.
Yeah, it's interesting. It's a very good observation. I have no idea about that.
Is it because it never actually calls where is pattern? Where is the draw pattern?
Draw pattern. Draw pattern. You define the function here.
Is
It's
it
an
not?
X and Y cow. How many cow? Right? Cow is for the square. You have 4 here. And shape.
No, I don't actually know how this goes, but could it
You
not
see,
be because?
No, it calls the function gradient pattern here. Gradient pattern you define here. Gradient pattern you define here. I'll think about you want to draw a square, the square here, right? And 4 here. Yeah, that's the way. Yeah, but yeah, I don't know why it go so fast this time, but for this one it goes slowly. Yeah. Any ideas? Now see, it works exactly the same. The way the 10. Let's see.
Yeah, why is that so slow? The most confusing thing.
Yeah, actually, really, really good observation. Very good observation here.
I mean, I'll look at that.
Any idea, guys?
No.
Yeah. So basically, the way it works exactly the same. You execute the function here. You have how many times for so hexagon you have to as at the position.
This is for data set 7.
Yes. So you draw the pattern. Oh, I see. I see. This time
Wait,
they do it
speed.
parallel. This time they do it parallel. Right? Oh, no.
Wait, no, scroll up. I could swear I just saw something say,
Second here. Second, no, what is this?
like at the top there, I could swear I just saw something say T speed.
Why is it so fast this time?
No, seriously, like scroll to the top of the program, I could yeah, right there below turtle, T speed.
Ah, Oh, that, yeah.
Set to zero,
Yeah.
so it's,
Okay, now let's see.
does that mean turtle has a default speed?
Let's modify this program here. See
Yeah, just
what
add
happens.
T speed somewhere.
Okay. Let's modify this one to see what happens.
Yeah. Yeah, it is.
Okay. Yeah.
Okay, so there is a default speed in turtle.
Yeah. So
If you want to go fast, set it to
do
zero.
they have do they have the function? Let's see. Let's see if I do not have I equal to T speed. Do they have this one? Green, or I can green here. Is that correct?
You might have to convert that to a string. I don't know if they output it as a number.
I don't know.
We shall now see.
No, I cannot.
It
Three.
says 3.
Okay, so the default for turtle
3.
speed is 3.
Yeah, that's three.
Can you put a -1 out of curiosity?
Okay.
Because like technically the lower the number, the faster it goes. But what
Let's
if
see,
it's
let's see.
negative?
Let's see.
In the name of science.
It's very fast.
Yeah.
No, I don't think it's the same. And so
No, I think
that-
it stopped, it caps itself
yeah,
at 0, doesn't it?
so if it's less than, no, let's see what happens if I have -10 here.
Fastest drawing in the West, boys, let's go.
Would you have to recompile it?
Nah, look at that, yeah, no, that's the same speed.
Yeah, I think.
Okay, so it does stop. itself
Okay, so
at
by
0.
default speed is number 3.
3 is default, 0 is fastest.
Yeah, it's a very good observation. Yeah, tech. Very good.
Glad I caught that, otherwise I would have gone home and wondered, why was it so fast? I want to bet it's up there in that little command prompts too, like T speed somewhere. Up in the top portion of this.
Yeah, this one.
Yeah, T speed.
But I think it's a slide mentioned speed.
We probably skipped right over it, didn't realize it.
No, no. No.
Of 3,
Okay,
skipped right over 1.
That's the new one. Yeah, I agree. Should see.
Okay, everyone, just so you're clear, T speed affects the speed of how fast turtle draws.
Mhm. Right. Okay, so now we move to the image processing. Okay, digital image processing includes the principle and technique for the following: the capture image, which device has a flash, scanner, digital camera, the representation and storage. Yeah, that's what I do want here. And it has the analog and the digital information. Computer must, the basic is the computer must use the digital information. We consider discrete value. I think yes, that. So basically, you have the definition of analog and the digital here. So think about the most simple one is when you think about the example when you talk here, right? The voice actually it is continuous in the range, right? In the range up and down, but it always is a continuous here. So if you want to transmit it, over from the source to the destination, in the way you work with the telephone voice over IP, getting by this one here, right? You have to convert it into the digital. And how we convert it into digital? Actually, when you convert it digital, you have to break it down into the multiple time here. You can think that it's a time interval, right? It's a time interval. You break it down in multiple time interval. So for each of the time interval here, it takes the value. It takes the value of this specific one here, and you convert it into the number. If you think about this one, right? So think about the volume of this one is the number 10, and this one number 15, and this one 35. You convert it into the number here. And of course, the more the interval it how can I say, the denser the interval, how can I say, what is it? Frequency, right? The frequency is the interval here. So if you take more sample, it's more accurate. If you take more sample, it's more accurate. But if you take less sample, it's less accurate. But you see, when you break it down furthermore, if you have increased the frequency when you take the interval here, it's more accurate for this one. But actually, when the voice it is quite sensitive to the sample. So basically, in the voice, I think it's a 4 kilobit. It's a 4 kilobit. Sorry, it's a 4 kilohertz. That means for 1 second. For 1 second, you have to take it to 4,000 samples. Right? For 1 second, you have to do it for 4,000 samples. So we do the same. We do the same with the image also, right? So basically, in the image, when you take with the old camera, it's analog camera. It's everything continuously, right? But when you convert it into the computer, you have to break it down into pixel here, right? You have to break it down into pixel here. You have to break it down into multiple coordinator here. So now you have to take what is the value of this one, what is coordinator, and what is the color here. That's the way it works the pixel, right? So see, you have when you break it down into multiple pixels, you have the coordinator of the pixel, and you also for each of the pixel, you have the specific color with this one, right? And of course, you see, you have the video, right? You have the 4K, you have the HD video, and you have a 4K video. That is the definition of the pixel here. The more you break it down, the more detail we have. And now I love photographic a lot. I have a lot of device to photograph. So you see, in some case, you have the video, the HD video, right? You have the HD video, and also you have the 4K view. And what do you think? Which one is for the color? Which one is the better?
HD or 4K?
Yes.
4K.
Why?
Is HD?
You have more detail, right? You have more detail. But the thing, when we talk about the photography, also we have the dynamic range. I think about this one. If you break it down into the 4K here, you have more sample, right? But for each of this one color, you only have the reflect in the 8 bit here. Think about this one. You will have 8 bits. That means the range of the color is
Just like draw again.
think about the range of color is always everything from 0 to 55. But even with the HD here is that you break it down with the HD. But for each specific pixel here, if you use a 16 bit of the color, you have the range from 0 to 65,000. Right? So that's why the camera is not only about the HD or 4K, also about the dynamic range of the color. The more dynamic range you have, the true color you can have, and the more vividity. Right? Okay, so basically that is the way you work with analog and digital. Here you have to convert it. You take the sample and you convert it into the pixel, and in the pixel you work with the dimensional grid. Right? You break it down the whole screen here into many grid here. And from that one, you take the sample of this one, take sample, and reflect what is the color it is. What's the color it is? What's the color it is? And you transmit it, right? And you can reorganize to the original color here. That's why some of the guys, they do not want digital camera because it lost the nature of the photo. By the analog, it keeps everything is originally. But when you convert into the digital, somehow you lost it because you take the sample of that. Okay, so once an image has been sampled, it can be stored in one of the many file format. It can be a draw image file. They save all the sample information, and the data can be compressed into minimize its file size. You can have the JPEG or GIF here. So yeah, when you take the photograph, when take program also we have the option with work with the draw image. That means you have the save of all of the sample information, and from that one you have total control of everything. So you can think about, you can change about the shadow, or you can change about the highlight of the photo here. And when we work with the JPEG, it actually is only compressed. The compressor, we have less control over the photo. Okay, so image manipulation program, it is a transform the information into the pixel or onto the arrangement of the pixel into image. You can rotate the program and convert the image from the color to grayscale, and you apply the color filtering to an image, highlight the particular area, and blur and sharpen. And we mentioned some of the technique here in this one. Okay, the coordinate pixel in the two-dimensional, it's ranging from 0, 0. See, if we work with the pixel here, it's ranging from, you can hear, ranging from this 0, 0 here. You can hear when you work with this, it's ranging from 0. It is a top, it's the upper, the left color, and you move everything to this one. It is a lower right color, right? That is when you have width -1 and height -1 here. The RGB color system is a common way of representing the color in the image here. Okay, so in the Python also we have an image module. It is non-standard and open source in the Python tool, and you can use it there. And from that you can generate. You have the image class represent the image as a two-dimensional grid of the red, green, and blue here. And you can check what you have on this one. You can use the image, and you can have image and image here. You can see what you have in the method and the function. Okay, so the following session interpreter does the following: import the image class from the image module, initialize class using the name small p, and draw the image. So what happened with this one? So you import the class image from the module image. You create the instance from the class here, and you draw it. Okay. So basically, that is the process of the display the image only. Display an image only. So see, you can go to the image you have here. Okay. What is it? Yes. So we can see what you have with the image here. Yeah, this one important. Tinker, the another graphic in the Python. I do not want to go with this one. Actually, we just need to know how to use it. You do not have to go into detail with this one. Otherwise, it overload.
That's a lot of programming to suddenly learn.
Yes. But I think I have it. I think I have. Yes. Okay, so this one is that you import image from the image here. Sorry, from the image you import the class and you generate it. You generate the instance from the class, and that one you have the file the bird .gif here. That's what I have here. I have about this one. That's a GIF file. So if you want to display it, you work with this one here. So now again, this one again. I got it here.
It just takes the first frame as a GIF.
You gotta go all the way to the left. Click on the bird if you want to move it.
This one.
No, like, the text that says bird. If you want to move the window, you have to click on that. Yeah,
Okay.
it's very weird.
Okay.
And since it's a GIF, it only takes like the first instance of the GIF.
It's very weird.
You won't see it animate that. You got to define that animation with a for loop, don't you?
Yeah, that's it. That's it, right? Or I range. And what have you? Image. Let's see what happened.
Darn.
Wait, can you like stop the program and then rerun it? Oh, never mind.
Yeah. So why?
It's only taking like the first
Yeah.
frame of the GIF.
Yeah, take the first frame.
Like you can see all the dots in the grass. They're about to fly up.
See how many frames it is. Let's see what happened if I do the one. Yeah, I think. Okay, so basically, yeah, so basically just do the first frame. It's really new to me.
Do you have to define that within image draw?
Yeah, okay, but this one you see, I have to close it for 1,000
You can just stop the program.
I know, but you see. Yeah, okay. Yeah.
Do you have to define that within image draw? Like how many it should draw?
Let's see what we have in draw here. Image, right? You see, we have image. What is it? What is the draw here? Class image. Get pixel, draw here. I don't know.
Yeah, it just, if I'm understanding that correctly, it just takes the first, it doesn't even recognize that it's a GIF. It just sees that it's a
Yeah.
image.
Yeah. Okay. Okay, so from the when you generate instant, right, you can bring down what is a instant wise and instant with this one here. You can modify this program to see what is it. Okay. Oh, that's fine. Well,
The other one got deleted because it was too small.
which one?
Yeah, no, your display console was too small, your terminal. Just rerun the program. There we go.
Okay. 200 and 175. That's it. That's it. Okay, so basically you can get the method get width and get height here. For this one. You can print image. Print image. It return you the file name width and okay. Let's see. See. Okay, good. So when I print the image, it print out what is the file name, what's the width, and what's the height. Okay. We have pixel, return, or tuple, value in the given. Okay. Okay. So yeah, so whenever we want to get the pattern of the how the color is mixed together at specific coordinate, you can use the method get pixel here. So let's see with this one here. With this program, right? With this program when you run it, I think about somewhere here. It can be
At 0, 0.
blue, right? What is the blue color? Blue is the combination of
Yeah, blue is just its own
RGB
thing.
would be, the last one would be 255.
0, 0, something.
I guess it'd be 255 and then whatever other variations.
okay. So let's see. Let print
It'd be 00255, or if you want to go for a brighter color, you go like, I don't know,
pixel of 0.
100, 100, 255.
I have to print.
You didn't put it in green. There we go.
0 here, right? I know 0 is here. 0 here. So yeah, it's blue. Oh, so
It makes sense.
yeah.
Because the last one, it's light, and that's the highest value.
Yeah.
And then any extra for red and green just makes it either brighter or slightly different color.
Yeah, that's why you go to the 254 here. Right? Okay, so we can use the method set here from that, right? So you go to specific coordinator and you set the color here, blue line. What's the blue line here? So you have image, you set it to 400 and 400, you draw it. If you draw it, you set the blue.
Blue is set to the bluest of blue.
So basically you have to use the combination of the right?
Yeah. Red, green, and then blue.
Okay.
But I only know so much about RGB because I debated it with a friend once.
Sorry. Right.
There is no defined starting point for image draw.
Yeah.
There we go.
Yeah. So you start thinking.
Yeah, the first one was it reached image, the first image draw,
Okay.
line 4,
That's why.
and now it's doing line 11 image draw after all that input. That's why the first one came out blank.
So that's why here, right? This one.
Yeah, that's all it had. That was defining the frame. Now you define the color and what you want it to do. Yeah, it should first
Yeah.
blank. And the second you close that, it should create the blue
So
line.
when you have the get high divided by 2, that means you at the center.
Yeah.
You have the center here. And for this one, you move to up high and you move to the center and you move to the down high here. And you see everything from the left to the right here. Okay, that's the way it works. Very simple. To set operation, write the image back to the system. Okay, that's when you want to modify it, when you want to modify it, and you want to set it. Now see about the bird here. You can modify it here. All right. So I can do it here. Let's see. I can do it for this one. For the bird here. image here, again, modify it. Oh, so why the blue? I also have to define the blue. So. Blue. Why the bird? Yeah. Blue. Now image draw it again. Yeah. So now you what happened if I want to save it? Okay, so new git here. I want to save it to the new git.
Make sure you know where that's getting saved to.
Let's see if I can save it or not. Save new. Okay, let's see. Do I have it? No.
Should be in the images folder, right?
No. Where did? Let's check. Oh, it not tell you how to save it. So I think it's the same. I think it's the same corner of the Visual Studio. Let's see. Code. Where yeah. Let's check. So why I save it?
The file.
Where is the current file for Visual Studio Code saved to?
Yeah, that's why I just opened it.
Because I'm thinking like it's the old file, read and write stuff here.
You can do save as and then see where it goes, where it takes you by default. Save new JIT.
Yeah.
Like check where the save as is for this Visual Studio.
Where's the Visual Studio? Where I see.
Does it save in the same file that you pulled it out of?
No, I checked it already, but not there.
Is it on the desktop?
Let's check. I don't know.
Like where is birds Python being saved to right now?
Python here. Python bird here. Bird here.
Okay, bird.
Yeah, so I suppose I think that it said new here. Sorry. New.
There we go.
Yeah, new.
Get rid of
You
that.
You can cancel that.
It's a new available.
Just close
you
down
can
the tab.
close that. It's not useful. Or you can close the tab because the tab next to it like that.
There it is.
Yeah, it's saved here.
And for some reason, it's saved to Microsoft Edge.
Yeah, why?
Weird.
Yeah, new here. Okay.
It is
Yeah,
a gift.
so that's the way you save it. Yeah. Honestly, this chapter is very simple and very straightforward. So you can play around with that. Okay, so that's the way you process an image. You can see the image. You have a grid here. You have the column and you have a row. So that's what you have. For this one, you have a grid of 3 row and the pie column here. So we have width, range, height, yes, that is a loop. That's a for loop, right? So we have to run it on the height and run at the width, and you can do whatever you want. For this one, you can change the color or you can do whatever you want. So basically, yeah, you can think about when you're processing image, you're processing with the grid here. Right? From the grid, you can run the loop. Right? So whatever you can run it, everything in the order from the row or the column, whatever you want, and you can totally flexible in when you manipulate the program. manipulate the coordinate. This is. Let's see. Okay, now you're converting an image to the black and white. Black and white. See what you have, the black and white. Black and white. This one. How it works? P5 black and white. Black 00, white here. Okay. So yeah, see for this one also, right? You run it in 0 here, right? That's why you see. You run it everything in the Y is a column, right? X is 0 here. You do the netted loop, and for every single pixel, what you do? For every single pixel, you get the red, green, and blue for every single coordinator, right? For every single coordinator. And now you divide by 3. Okay. So if you less than 228, you have a black. So basically, it is contrast here, right? So less than 128, it is black, and you set the pixel to the black here. And if not, you set it to white. So you mix draw black and white. You mix draw. You can run it here. So see, you convert it to the black and white. White. Here.
Yeah, there we go.
Black and white. So if you want to save it again, you can use
Image save.
whatever image save. Save.
Do GIF.
Sorry. BY.
There it is. Give it a sec. There it is, and it should be in the same folder.
No.
Right there, yeah, you have it selected.
Where? No, this is Python. So I have to refresh.
It's,
This one.
yes, DW.
I'm still wondering why it saves it to Microsoft Edge.
It's opening,
With default.
yeah, it's just
Default image opener on his setup.
It's not Edge though, it's Internet Explorer.
So it's even worse.
That's the only thing that's defaulted to open a GIF file, I guess, for this thing.
Okay, so this one also very straightforward. Yeah. Okay, now grayscale. What's the deal with the grayscale here? Let's see, you get it. You divide by 3 set. You change it to you flat it every.
Value,
Yeah.
So instead of defaulting it to black or white.
Yeah, you flat it out.
Mhm.
Okay.
So that the RGB all have the same value.
And it just stays the
And
same, yeah.
let modify program. See what happened here.
Because black and white is literally just, what is it? It's either going to be 000 or 255, 255,
So you have to
255.
do the right.
So then black pixel can be changed to average.
Yeah, average. So basically, you have to that's one. You have I think.
You can just ignore that and just change black pixel to average. Yep.
No, but the thing is, average here is only one value. You need 3 of them, right? You need a tuple here. So you cut.
No, I guess that's true.
Average. Okay, so you have to put new kind. See what I have to.
Then we can just get rid of them.
Yeah. What? Yeah. the grayscale. You just black it out.
Mhm.
Yeah. Okay, so here luminance.
Luminance.
Okay, okay. You will manipulate it, right? So for the red, we time it to, I don't know what is the point. This one, it make it. That is gray also.
It's just
That's gray.
or cheap.
Really? See what's the gray? Okay. Is that manipulated?
Mhm.
Okay. You got the red here, green, and you sum it up together, and you also you plug it. I don't know what's the point. This one.
I mean, each one of those, just green's gonna be the highest value.
Illuminate. Anyway, that is the way you manipulate it. So anyway, that's a very simple. That's a process principle here. Right? You have to maintain the loop. You run it every single coordinator in your picture, right? By running everything in the Y and the X here. Or you can convert it. You can do the X first and Y later, whatever it is. Doesn't matter. Oh, that is copy here. Okay, that is a clone. Okay, the clone method. The method clone view and return image. It's the same attribute, but with an empty chain as a pioneer. So I draw it. Unit. Okay, I clone it. I clone it as a new image. I grayscale. Grayscale image. Let me draw. Okay, so it's the same attribute as original one, but with empty string at the back. What does it mean? Sorry, it's not sense for me. So for this one, right, you open the original one, you draw the original one, you copy, clone it, and you draw it again. Now you change it. Okay. You change it to the gray. You draw it again. Okay, so we see what's the difference between the new image and image here. Image here. Do we have a copy here? No. Why I don't have the file here? Why? Maybe somewhere. Clone it. So see what happened here. You print out the file. You clone it to the new file. You draw the new file. You change the new file to gray. And from here, you print the gray. And this one, original one here, right? Okay. So basically, that's the clone. You just modify everything in the clone only. But the original one is keep the same. Right? That's the purpose of this one, right? So why is it made? So that original one, you can change that original one. Now you copy it, clone it to the new one. You draw the new one. The new one exactly the same, right? So now you change it to the grayscale here. You change it to the grayscale. Yeah. But now you go back to the original one. So okay. So that also good. So basically you just want to copy to another one and you modify the other one. You can do whatever with the other one, but the original one it keeps the same. Now you do the blur. How we do with the blur? Now see, shade down with the blur. You can open the file. Shade down with the blur. Where the blur? How we do it? You have the triple number 1, triple number 2. We return. You add them up together. Yeah. So basically, you just add them up together. Now you have new image clone. You clone it. If the user loop here, you get it. Okay. So basically, for each of the coordinator here, each of our coordinator, right? You have to get it every surrounding coordinator, right? You see, you get the original one here, you left, right, top, and bottom here, and use the sum. You reduce here, triple sum. What is it? Is that it adds them up together, right? You learn the reduce already, right? Reduce here, that means you define the function, right? And you know that you have the O, left, right, top, and bottom. You just add them up together. Right? And again, for this one, you use the average. It's 4. You have the map here. You divide by 5 because you have 1, 2, 3, 4, 5. You just add them up together and you divide by 5. You just divide by 5, and now you set it, and that is the process of blur. Okay, let's see. That's the process of blur. So we just got the attribute of every 4 corner, and we do add them up together and divide by 5. How would blur? You plot it out. Where have my sheet? You have the sheet here. Okay, I got it. That's the original one here. Original one. Now see how we blur it. Take a while.
It should take a while.
Oh, not much. She doesn't say much about blur here.
It's only slightly. I feel like it'd be better if you had more detailed colors and stuff like that. The image itself is fairly simple, so it's not going to feel like it's blurred.
Okay, this one is more clear, right?
Yeah.
This one more clear.
Basically, the edges get a little blurrier.
Okay, so that's the process. You just got every coordinator around you. You just sum it up together, divide by 5. That's all. That's the process. Okay, so we have the sum with the edge detection and so. So basically for the edge detection, I think, what is it? Left, bottom. Okay, I do it again. Average here. Absolute. It's a highlight. Okay, now we do the reducing the image part. You somehow, right? So the size, the quality image on display medium depend on the 2 factors. The first one is the width and the width. Width and the height, and also it is a resolution, right? How many you want to break it down? How we want to break it down into the coordinator here? Resolution is that they want to define HG and okay, right? The more pattern you have, the more clear we have with this one here. A size reduction is really a preserved image aspect ratio. You keep the ratio the same, and it can reduce the image, throw away some of the pixel information. Now you have the reducing the image here. How it works? Reducing the image. Reducing image here. I will work with reducing. Let's open the reducing to see how it works. Reduce resize. Right here. That you have a factor. That means you want to resize into the factor 2 or 3 or 4 here. So you have width, you get width, and you get height. Okay, that's the first step here. We have new image. You just generate the blank one, but the size is divided by the factor here. Oh no. Let's see what happened with this one. Oh, it's high. Minus factor. What's the process? What's the process? You divide by factor. You divide by factor. You set the O and the Y O. Minus factor. What do you think? What's the process? You have
Shrinking the image, so we got old and new. Old is less than with minus factor.
okay, so see, let's translate it. Let's translate it here. Think about you have the original one here. Right? So now if you do it in half, right? So basically that's the new one here, right?
Yep.
Yeah, new one here. So we have O and new starting O starting from this one 0 here. YO less than high minus factor.
With minus factor. Factor is coming from.
Factor from how many you want to decide, right? You decide in the 2. So basically you have you minus 2. You minus 2. YO less than high minus factor.
Oh, so what it seems like what it's taking is, so let's say you have 10 pixels
Yes.
of color,
Now we have a file.
and you want to cut it in half. So what it's doing is you have 10 in length, and so it just checks every second, every.
Okay, you skip it, right?
Yeah, you skip.
Okay, yeah, no, right. Okay. So we have to sacrifice the image quality for this one.
Yeah.
Okay, I got it. Okay. So, but yeah, right. So basically, you have. Right. So you see.
You're 9 for all.
So basically, you see, you have this one, right? So think about you have the 10 pixel. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And also 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we see you just pick one from here, right? And you pick one from here and pick one from here. You skip this one, skip this one, right?
Yeah.
Right. That's the process. Yeah. But again, this one you have to sacrifice the quality.
I think it also skips,
Yeah, you have to
What
do
is
the same
like
with this one. So,
with voice.
yeah, so you have to do this one, right? Yeah, but you need to do this one. Yeah. Yeah. Sorry, not this one. This one.
Yep.
Yeah. The process is the same. The process is the same.
That's the original image, and then if we
That's
shrink
it.
it. Yeah.
Okay, so I think this chapter is very simple. It's very straightforward here, and also we have a lot of the program. You can download it from the student from Cengage. You can go to Cengage here. Download the data file. And this one. Okay, so on Wednesday we go with the number chapter 8 in the Cengage. In the Cengage.
Wednesday?
That is the most thing you work with the final project with the graphic here. I don't know what is the homework you have for this one.
So it's, you gotta do T-Kenter, I believe.
You can do whatever you want.
Oh, really?
Yes.
I
don't
only
care.
know it's
It
T-Kenter.
provides that it shows the program correctly and it's not correct.
So you're not requiring T-Kenter to be the only thing we need.
Seeking the, I think it's more traditional one, and it's
It's
Yeah.
also painful.
Okay.
I think, what is it? I've done the T-Kenter assignment, but I could be wrong. They are fun. If you wanna look at it that way,
Fun?
they're not really that fun.
Okay.
Yeah, okay, so the programming assignment is to do Fahrenheit and Celsius conversions, which isn't bad because they give you the formula for it. But T-Kenter itself doesn't make things easy. I had to copy paste a whole bunch of different places just because I couldn't understand what it was doing.
I don't know why they changed it. So back then in the other at that 140 they work with the seeking, but now they changed it to the high what the name is there. New module. I forgot it.
They, in the book, they use like easy, like breezy.
Yeah,
easy,
breezy.
gooey or something like that. It's really, like, T-Kenter is not that intuitive, in my opinion, so do what you will with that information.
Anyway, you can do whatever you want. You can do with the indicator of easy, the same with the book, whatever.
Whichever GUI that.
Okay, so we're gonna continue this all
Okay,
Thursday.
so I see you guys on Wednesday.
on Wednesday.
Bye bye.
Thursday, right?
Sorry, Thursday. Okay.
I can see you Thursday.